Hi everyone. In this demo, we are going to look at our improved shopping agent v3 that's built on top of DAG, which stands for Directed Acyclic Graph. Before I jump into the details of what happens under the hood, let's quickly jump into the agent itself and let me kick off a search for Bluetooth mouse. And let's go back to the README file to continue explaining the architecture. So DAG in simple terms, what it does is based on the user query, there is a planner agent that takes care of building the entire set of nodes in a graph so that the agent knows exactly in what order the nodes have to be executed, just like we would plan upfront how a project works. So the entire plan is created upfront and then executed, and this also enables us to do a lot of parallel processing as well. So as part of this shopping agent, we also built three specific skills. One for shortlisting the products based on the search results page. We also have code generation blocks that will help for sorting the list of products based on reviews and so on and so forth. And we also had product analysis that does a deep analysis of each of the products, the shortlisted ones, and then the final recommendation. With that, let me quickly showcase the gateway as well that powers this entire search. So you see here, I've slightly modified the gateway from what we saw last time, where this gateway has multiple versions of Gemini Lite. That way, even though there is load balancing of different queries, it's all sent to the same model. That way we get a more uniform standard results. So I've created multiple projects and used API keys of multiple projects to kind of manage this load balancer. That way we are able to use Gemini, which is the ideal model that we wanted based on the past testing across different cases. In this case, I almost have about 7 API keys for just Gemini Lite, and Flash and NVIDIA and Olama is just things that is needed as if this is still not enough. And you can see that we are almost touching about 300, 200, 100 odd queries just on the top three uh, modules itself. That shows the amount of calls that these agentic systems would need. So that's why a strong LLM is really required. With that, let me jump into the search result page and how it looks like. This is very similar to some of the old projects that I've shown in terms of just the layout, but what this is supported by is the DAG architecture, as I mentioned. So just to summarize, the shopping agent has a summary of what's the recommended device that you need to use, along with the details of the individual top 3 shortlisted products. And each of these products has 5 different dimensions based on which individual LLM has evaluated these products in terms of, and also it has color coding of whether this is good with respect to customer sentiment, reliability, value for money, feature completeness, and build quality. So that's the high level flow of how the agent looks like. Let me jump into the code to explain how things happens under the hood. So let me go into the graph itself to explain. I think I have the JSON and the logs. So yeah, so this is the logs of this particular query. So as you can see, it has, let me go into the graph HTML view. Again, this is something that I built for better visualization of the graph. So yeah, so you can see that there is a system prompt for the shopping agent and there's the user prompt. And this is the graph. And here you can see that here you can see that it starts with the planner agent that creates the entire graph. The first is our own custom skill, which is the product shortlister that analyzes the search results page and picks up the top 10 products. And then it uses the coder to kind of rank it, sort it based on the descending order of reviews. It chooses the top 3, and the output of this coder cum sandbox executor is then passed on to the product analyst skill. Again, this is a custom skill, and here you can see three parallel fanouts happening, analyzing the three products individually. And then once the analyst completes, it goes on to the another custom skill, which is the product recommendation skill, which looks at all the three responses and then finally creates an output. And then we have a formatter skill that analyzes the output and ensures that this is in the format that is required for our client, which is the web portal that we have. So that's the entire flow. Let me see if I missed out on calling out any of this. As we mentioned, this has a parallel fan out. It has the dynamic ranking via the coder. It has the custom skills that we built. And I think this is the graph and the log that we explains. So that's the quick explanation of what happens under the hood for this agent. Let me jump into some of the other queries that we wanted to showcase as well. We have covered the shopping agent for now. In the next part of the video, I'll just talk about some of the foundational queries that we also executed to understand and test the DAG architecture. So let's start with the hello. So this is a simple query called say hello. As you can see, the planner just creates a response by itself. The LLM creates it by itself, and then the format, it just ensures that the output is in the required format. And this is the corresponding log for the same. Again, simple enough. Next, we'll start off with getting the details of Shannon Cloud from Wikipedia. As you can see here, the planner creates a node for researcher, which extracts the information from Wikipedia. Then a distiller extracts the information of his birth rate, death rate, and his key contributions. And there is a critic node which ensures that the distillation process was accurate. And you can see that the planner node has actually dynamically placed the critic node as part of this query itself. That's how the architecture is robust and smart enough so that this extra validation is actually baked in dynamically. And then the formatter ensures that it's in the required format. So that's the visual representation of the same. And the same thing is there in the log format as well, along with, you can see all these nodes and the corresponding timestamps of the same. Next, let's move on to a query that really tests the fan out. We already saw the fan out as part of the shopping query, but this is the foundational test query that we had. So here we are trying to check the population of London, Paris, and Berlin and see which two are the closest in size. As you can see, the planner has fanned out three researcher agents analyzing the three cities population, and then a coder agent actually compares which two is the closest and then creates a formatter query. The same thing is available in the logs as well. You can see the first planner. It keeps going, and then you can see the three researchers. We are not waiting for one below after the other. The maximum researcher query is 12.4, so this is the time that will be taken for the entire research work. And then the other queries. And you can see the different gateway calls as well. As I mentioned, because we have multiple Gemini lights configured with different keys, you can see consistently across fan outs, the same model is used to analyze each of these fanned out and parallel queries so that we have a more standardized results. The next one, we will talk about a simple a failure case where there's no specific text in this query, but we are still asking it to extract and tell us. So here you can see the formatter is just complete because there's nothing there. And you can see from the logs itself that it says that the data cannot be retrieved. Just a normal graceful failure case. The next one is a more interesting one where we will talk about the advantage of DAG where we intentionally kill the process midway. For example, this is a query about inquiring populations of three cities and then identifying the growth rates. Here you can see we actually killed the job after two of the researchers complete and the third one was not complete, and which means the rest of the ones are still pending. you will understand this better if you look at the logs. So you can see here, this is the logs. Where did we have here? Let me see. Looks like, for some reason, I'm not having the right log here. Let me jump into the README file because I pasted the right logs there to explain this case alone better. Graceful handling we covered. Yeah, so this is the killing of the process. So here you can see the logs that, yeah, so the process is successfully terminated by kill. That way the process ended. Now the best part about the DAG architectures is this can be resumed. So you just need to use the resume command and mention the exact session ID, and you can see that the same session gets um, invoked. So you can see this is the session, and the same session is getting invoked. Hold on. Yeah, so the same session is getting invoked here, and the remaining nodes gets executed, and then the final results are shown. So here you can see this is the resumed log. As I mentioned, now you can see the same job. This third researcher is also now complete, and the remaining nodes are also executed. And this is the resumed log here as well. So you can see, see, only the third researcher is now running because the other ones got completed as part of the first run. So only the third researcher is running now, and then the remaining nodes get executed and then completed. Now let's talk about, I think we already talked about a critic case where it was passing. Now let's touch upon the critic case where it is also failing. So here you can see this is a query that we have to check specific details and Claude Shannon, his birth city, and write a haiku based on certain syllables format. And here you can see based on the image that a planner is created, researcher is created, a distiller is created, and then a critic is created, and it checks if the output of the haiku is following the specific syllables format. And in the first case, it didn't succeed, so that's why the formatter is skipped. And because the critic didn't succeed, the planner automatically creates a new graph, and you see the nodes are a continuation of that. Planner creates a new graph and executes the same flow, and then now ensures that the critic is actually complete and the formatter is also complete. This can be seen better in the logs as well. So here you can see the first attempt, critic fail recovery is happening, and the second time it ran, it was now successful. So this is an example of both a negative case and then reattempt by the planner agent itself, and the positive case we already saw as part of I think three city populations, not three city populations. I think that's part of the Shannon Wikipedia. So I think that's some of the basic queries that I wanted to cover. Let me go ahead and check once again in the README file if you have missed something. As we mentioned, we talked about the shopping agent, how the DAG is using it to create the custom agents, the different custom skills that we have uh, that's powering the same, and a lot of the foundational queries that test the DAG architecture. So that's the end of the demo. Thank you.